Okay, so today's lecture, as well as Monday's lecture, will be the core for your next midterm. Okay. If you know, this Friday we won't have a class. It's a university holiday, so I cannot host a class. But if you have any question, that please feel free to ask me that day as well. Okay, in between. So let me see. I'm already recording. Okay, so this is the concept we talked about last time. It's called remote procedure call. This allows you to have a program that's going to be running and calling a function that's being served via the program. And we will be talking about a concept eventually looks like this, is that in fact, it's not just about the function, but what is the object, what is the object in the programming related to this kind of scenario? We will be, hopefully at the end of this lecture, I will be talking about that you essentially create what you really want to interact with is the remote object, which is, I'm always use label GPS in the example. This obviously could be a thing and could be a person or whatever. And you really want to interact with a remote case. But your program over here, they will thought that this remote object is local. So essentially, the local, we have a proxy or we have a shadow copy of that object. But through this mechanism, you thought you're interacting locally with some object-oriented from a programmer perspective, and yet your program is basically touching everybody in the whole world. Okay, so we're going through 3 GitHub folders today. So one is GitHub 007, which I will show you the basic remote procedure call. I already showed you the example last time. So this time I just want to go over this very quickly. And then we go through CPP08, which is talk about remote object, RO, which means that you just directly, without a shadow, you directly interact with another object remote. And then we talk about CPP09 is called proxy object. Proxy object is that this scenario that you create a local shadow for remote object from the programmer perspective that I deal with object just like I deal with the object for your first whatever 3 homework assignment you're reading you have developed for C++. You thought every object is local, but the thing is that that proxy has a mechanism to look for the real object around the internet. Okay, that's what we want to talk about today. And then next Monday, I will talk about yet another topic related to this is object mobility. Means that, okay, this object is remote at the target. I want to move it to my home. What does that mean? I can actually move the object from one location to the other. Okay, so so let me first look at the first scenario. Let me go over here. Okay, let me go to CPP 07. Okay, so if you look at the GitHub directory, take a look. Where's my GitHub? Okay, I have to go over to GitHub. I'm looking at this directory, GitHub 07. It's only 4 files. One of the file is, we call it the remote procedure call specification file. And then I have a client, and then I have a server, and then I have a make file. That's all you need. So let's first take a look at the take this file. This file, I instead of saying call it a web report, now I call this function remote print. I want a remote program to help me to print a message. All right, so that's the client. So server is going to do the print, and the client is going to send the content to be printed. Okay, so this is essentially a printer scenario. You can see that this, by the way, this program is written in the JSON syntax, is a specification that you need to provide to do the remote procedure call, because you have to say what is the interface between the client and server under this situation. So you can see that it has a name of the function, always have a name, always have the parameter, and always have the return. So you basically just specify the three things, and that's how you need to. And then we take a look at the make file. Let me see, go back. If you take a look at the make file, what the make file is doing, among other things, is this line. That this line is calling a program called JSON RPC stub, which is already installed when you did the first two homework. You already have this installed. And what it does is take a first parameter is the JSON file I show you, which specify the interface. Essentially, this JSON RPC stub is using the interface you just defined to produce the .h file for you to be able to complete the function. And then you provide some name. You say the server name should be WR server, the client name should be WR client. Okay, so that's the only thing you need to do in order to run this program to generate. Okay, so you should be able to do this. If you don't want to do it now, you can do it later. So this is a for program. You just simply type make. And let's take a look this a little bit closer. The first thing is it run this line I just showed you. So after it run this file, look at this. At this moment, I only have this four files. If you take a look at right now, I introduce the WR server.h that was generated and WR client.h. These two files are generated. Okay, and after they generate the file, then I run the rest of the line. I compile the WR client.cpp, I compile the WR server.cpp, and finally I can create an executable for my client, WR client. I create an executable for WR server. So now I have two programs I can interact. So let me just show you how you can run the program. To run this program, you always run the server first. So if you think about this, if the server, let me first run the client. If you run the client, it will say, you can see that it will say what? It will say exception. It will say client connector error. Why is a client connector error? Because the client tried to connect the server and the server is not there. And therefore, it basically sent out the RPC request to the server. And now it says cannot connect to this particular URL because the URL is the, how do I say that, locator for the server. Okay, so this, it tried to connect to localhost 8300. So I want to tell you that how I specify 8300 is actually in WR server.cpp. So inside the WR server.cpp at the end, you can see that I set up an HTTP server and I put a port number. So when you run the program HTTP server, you have to specify what port number you're listening for incoming requests. So this is essentially how I set up the 8300 become the URL. So essentially, if you do it in today's web, the default port number is either 80 or 8080, 8080. So that's why you can see that I'm actually creating a customized port number. So I create a customized port number like 8300, so only my own client can communicate with me. Okay, so that's how you set it up. Okay, so after I done this, I can start. I have to run the server. So I said WR server. If I run WR server, you see that the server object was created. Okay, it's already running here. So I have to use a different window. Let me use another window. Okay, this window here, I have a client, WR client. So this time when I run the client, it says, okay, the status is successful. Remember last time I did that about a minute ago? It says that I cannot connect, but now it can connect, so it will return the successful. But then now we go to the server, you can see that the server is receiving this request. It's receiving this request called remote print. And this is the content that I want the remote to be printed. Okay, so that's a very simple program. You can see that I'm creating one remote procedure call. That call is called remote print. And I can send it from the client to the server, and then the server is doing the print. So server is doing the real function implementation, while the client is just making the call. Okay, so this is a remote procedure call between the WR client and the WR server. Okay, any question about this example? Yes. Okay, which one? Okay, the .h file is created by this line. Okay, let me do this again. Let me copy this line. So let me do a make clean. You can see that there's no .h file, right? So this program, the JSON RPC stub, it takes the ecs36b WR JSON, which I show you at the beginning of the class. That basically specifies the interface for the remote procedure call. And then I provide some kind of name. Let me actually change the name, okay? Let me change this to ecs36b. And then I change this to ecs36a. Okay, I just changed the name. I changed the label because this is going to impact the file name, the .h file I generate. So if I run this, and if I do an ls, you can see that I generate ecs36b client.h, and then I also generate ecs36a server.h. You see that was generated, and to control the file name, you have to use this two argument, the CPP server, CPP client. Yeah. Okay. Any other question? So this is the program that you need to get this to work. Anybody have any question? Let me just show you very quickly about what the client program looks like. The client program is very simple. It's only a few lines of code. Is that you create a HTTP client object, and you create the WR client called my client, and then you essentially call the my client.remote print this message. Okay, this particular function. And what is my client.remote print? It was defined under, in this case, is ecs36b client.h. If you look at this, in ecs36b client, I define the function called remote print over here. And the remote print eventually will call, putting the argument together is going to do call method, which is going to send to the remote. Okay, and the remote server is going to be receiving this. So let's take a look. If you go to the remote is WR server.cpp under here. Here you see that I have a function, and this function is called, it's a member function of this my WR server. The member function's function name is remote print. So essentially, when you call that remote print at the client, through the interface of RPC, it will direct it into this remote print in the other program. So this is called remote procedure call. Okay. the important thing we want to accomplish here is that you don't have to run everything under a single program or a single computer or a single network point, but you can distribute your function around whatever is networked, and then you can just communicate, and yet it looks like you're running the same program over here. Okay. Any question? Yes, please.
Yeah, I have a question about the W client, my client, client. The last part of it, JSON, RTC underscore client.
Which part? Is this program? Yeah, this is WR client.cpp. Is that WR client CPP or W client.h? Okay, okay, so this is the program. Which line that you're? Let me go to the GitHub. It's probably easier. Okay, you said line what, 22? Okay, so essentially what this line is that it's, remember in object-oriented programming, everything is an object. So when I want to create a client or server communication, the server, I create a server object for my server, and the client, I create an object called my client. So my client is an object. So essentially the way to parse this is that I have a class. The class is called WR client, and the object is called my client. Okay, by the way, they're not using what we call bracket initialization. They're just using the old style, the parentheses, but I can change that. Let me do something to show you that. Let me make it clean again and I need to, let me modify. This should be equivalent to this. Just maybe for some of you, you feel more comfortable this way. So you can do bracket initialization like this. And this one, I can do bracket initialization as well. This is also constructor. By the way, this two line, they're both constructor to create a HTTP client object and my client object as well. Okay, so let me try to see if this will compile without any trouble. Yeah, it will work. Okay, so it's just constructor. Any other question? Okay, so now I'm going to move to CPP08. So this one is just a function to function. But what I want to do is that I want to make a call to the remote object. I'm not only call a function, but I want to call a member function of a class. Okay, so first let me go to the other directory, CPP08, which in the GitHub, now you can look at CPP08, I call the remote object. So over here, you see that all our old friends are here, okay? Not just I have what I call, because of the remote object, I call it RO client, RO server, and I have the RPC specification file, which is ecs36b underscore ro.json instead of wr.json. And then you see I bring in GPS, label GPS, all this classes over here. So let's see how do I put all this picture together. So we always first look at the RPC file. The RPC file defines what function has been defined over here. So I define two functions here. One is called set GPS label. This is a function I want to set, because of the label GPS, I want to set what's the label of that remote object. And then I have the other function, which is also we should be really familiar, is dump to JSON. I want to call a dump to JSON of a remote object. I want you to create a JSON representing whatever object you have on the other computer, and then you will send the whole JSON to me. So in other words, I will be able to see what the remote object looks like. Okay, so that's the two functions we define. One is set set GPS label. One is called dump to JSON. Okay, all right. So you can see that the action, and then okay, there's a little bit different I did here. Is that now you see the parameter? I have a two extra argument. One argument is called class name. One argument is called object ID. Okay, so think about this. Now, what we're doing is I try to communicate with the object that's actually sitting on the other side of the world. So from the programmer perspective, I can imagine that computer must have a lots of objects. Lots of other, but by the way, this is a difficulty because I no longer can do what do you call memory address or reference, because each of the memory address is very unique to each of the computer. And the thing is, by the way, it's really unpredictable. Before you start the server, I cannot predict what memory address will be used for a particular object. So we need to introduce another mechanism for us to identify a particular object instance that's on remote. That's called object identifier and the class. Okay, so we need to, when we communicate with any function, we need to have a class name. We need to have object identifier. Similar for dump to JSON, I have a class name and object identifier. So with this two, I will be able to communicate with an object that's actually survived in another machine over there. Okay, so let me take a look at what's happening over here. So again, I will do make. Okay, by the way, you can see that the same thing. I don't have RO client.h. I don't have RO server.h. Those two files hasn't been generated, so I have to do make. And you can see that the first line is JSON RPC stuff, ecs36b RO, the different specification JSON, and CP server is our server, CPP client is our client. So this should give me both our client.h and as well as our server.h and client.h. Okay, those two functions are being generated. Okay, by the way, to learn RPC, it's really good for you to understand the code that's generated. Not just understand the RPC, but you will be able to see what kind of object-oriented code that's industry strengths C++ code that's being produced and being used. You can see that why we have this this particular particular style of code. Oh, by the way, I forgot one thing. If we take a look at the code, let's take a look at RO server.h. This is code that's generated. And in this code, it has two functions. One function is called over here. You can see that there's two functions. One function is called set GPS label. And the other function is called dump to JSON. Okay, there's two functions that's defined. And then last time, I forgot who actually pointed out, it's very interesting that they did this equal to 0. They do this equal to 0. So what is equal to 0? Let me use the other program to explain this. So this is an instruction point about pure virtual function. So what is a pure virtual function? That is, it ends with equal 0 and then semicolon. Okay, if you have this like this, it's a virtual, it is a pure virtual function. By the way, when you communicate with a compiler, when you specify a function signature and you say it's equal to 0, that means that it doesn't have an implementation. It means that this is not even a real implementation. It's just basically saying, hey, I define something called virtual function, and I expect some of the derived class will provide an implementation. But all I'm doing, I'm just providing a function signature for this particular member function without providing a function. So why we do that? Okay, first I want to clarify what is a pure virtual function. Pure virtual function is saying that I just want to specify the interface or function signature for this particular virtual function, and yet I'm not providing an implementation. I'm expecting whoever inheriting from me will provide the implementation. And the second thing is that why we need to provide this mechanism called pure virtual function. This is essentially trying to force your derived class to provide an implementation for a particular function is specified. And which means that because I don't have one, you're in trouble if you don't implement, because then your function is not going to be connected to anything. So that's why you have to, if you want to enforce whoever inheriting from this particular class to be compiled successfully, you have to provide a function. Let's try to show you an example. I want to go back to CPP07. It's probably easier for me to do that because this is everywhere in the CPP 07, 09, 08, and next week I will give you 010. They all use pure virtual function. So let's take a look at again about WR server.h. So the pure virtual function is defined as a remote print. Okay, remote print, this is a function that's a pure virtual because it has a equals 0. Okay, so now if I do this, if I go over here, by the way, this is the, I would say the easiest error that somebody will make, okay, as a programmer to deal with a pure virtual function. So the virtual function is called remote print, right? And let me do this. I forgot, by the way, this is so frequently happen. I forgot to add the my WR server. So instead, I just call remote print. Okay, I just call remote print. By the way, this code can still compile. Let me show it to you. This code can definitely compile. I would just make WR server dot. Oh, if I compile this program, I can generate a code. So this program syntactically is correct. But if I try to link it to it, you can see that when I want to link this program, it will say, hey, let me see. There is a V table for my WR server reference from whatever is actually missing. So whenever you have a pure virtual function, you don't provide an implementation, you're going to get into this. Okay, let me tell you another easy mistake you have. If over here, I actually remove this line. Let me remove this line. I remove this line. Okay, it's a virtual function. I don't have to have it, right? It's a virtual function. I use my parents, so I do this. Okay, and I try to, if you compile the program as an object file, it will tell you that this is a compiler. It will tell you, you can see that variable type is abstract class, and there is an unimplemented pure virtual method, remote print. Okay, so you can see that the compiler actually realized you try to create this class, but you have a pure virtual function or pure virtual method. It's called remote print that you never specify under this my WR server. That's why a lot of you will get this. By the way, in the past, for ecs36b student, they look at this arrow, they say, what does this mean? I mean, you have this whatever type, and then it usually start with this S and saying that, well, there's nothing about this message. This means that you forgot you forgot to implement in the class definition a virtual function line which corresponding to the pure virtual function that's specified in the one of the base class. Okay, so this line must be there if the base class define a pure virtual function. Okay, that's a lesson to you that I will just comment here. This is a pure virtual function or method. Okay, hello. We need to have it. And then I'm going to modify this back. Both these are now we compile, everything is okay. All right. Any question about pure virtual function? All right, so now I'm going back to CPP 08. Let me just make sure I get everything compiled. Okay, so I have the client and the server. Let's take a look at what the client is doing, okay? So if you go to wrclient.cpp, so the first few lines, they're just like the CPP 07. You create HTTP client, you create a my client object, and now let's take a look at what's happening. Instead of calling remote print, I'm calling my client.set GPS label. And then you can see that I provide the argument and the function is set GPS label. The label itself, teaching and a learning complex. And then I provide the class ID and the object ID. By the way, remember what are the things? Let me take a look at this. If you go to the ecs36b ro.json, if you look at this, the way I present the order is action, class name, object ID, and the label, right? The parameter should have this 4 label, which is the action, class, object ID, and label. Okay, let's take a look at the code generated. .h, that's the code generated. And if you look at the order of the parameter, it's action, class name, label, and then object ID. So they flipped the last 2. Okay, it was the order of action, class name, object ID, label. But over here in the argument, it is flipped a little bit. The first 2 is action, class name, and then the last 2 is label and the object ID, right? It's different, just to let you know. What they did here, you might want to guess, is that when the RPC start program, when they create the function prototype, they pick the name of the argument and they order them alphabetically. So the whatever the order I provide over there is not alphabetic. I'm just saying action class, but the O and the label, okay, O and L got flipped in the code. So that's why when I call the program, call this function, I have to watch out that the 3rd one is the label, the 4th one is object ID. Okay, so let's go back to this code. So now you can see I call this function. I call this function set label, label GPS. Set label is the action, and label GPS is the class name. And then teaching and learning complex is the label I want to set to that GPS object. And then the object ID is 1001. Okay, that's basically I set up over here. So now with this, I can call the remote function called set label. And then similarly, when I want to call dump to JSON, if you remember, the dump to JSON has 3 arguments only because it doesn't need a label. That's why it has action, it has a class ID, it has the object ID. So essentially what I'm doing here is first I set the label, and then I basically dump the whole object after you set the label, and then be able to see whether I set it correctly. So that's the two functions I'm running from the client side. The client side is really just simple, just like this and this, you're done. Okay. All right, let's take a look at the server side. Let's first run the program before we go to the look at the server side. So again, I have to run the server first, and then I will go to the client. Sorry, I have to go to CPP08, and then .ro client. Okay, you can see that I make two calls. The first call, I got a status successful because I set the label teaching and learning complex. And then I do a dump JSON. I'm actually getting teaching and learning complex. Okay, so that means, hey, let me actually change one thing to show you the more action here. So if I go to my client, I did a dump to JSON before the set and after the set. So I can just copy this piece of code. This is dump to JSON. I'm actually going to do that. So I'm calling the dump to JSON first and set, and calling dump to JSON again. By the way, you're really encouraged to just doing this kind of modification to show you actually understand how the code is doing. So now I can do server, and then I'm going to do the client. Okay, so you can see that before I did the change, the label was Costco and Woodland. Okay, that's by the way, that's the object in the remote. And then after the set, I actually got the teaching and learning complex. And if you come over here to see the server side, that this is what I did, right? The server side essentially received a dump to JSON calling. This is dump to JSON label GPS 1001. And then this is what I return back to the client. This is a server side. And over here, I'm just running a set GPS label function. And then I dump it again. So that you can look at the compare between the server side and the client side. You can see that they're actually collaboratively to complete the program this way. Okay. All right. Now let's take a look at the. Hold on. Now let's take a look at the what do I call it? The server side, very quickly. Okay, inside the server side, let's take a look at the program. Okay, this part you can see that is just the inheritance from those two functions. I have to define because they're both pure virtual function, both set GPS label and dump to JSON. They're both pure virtual, so I have to define here. By the way, if you notice, with the JSON RPC, everything is a virtual function except the constructor, but everything else is a virtual function. Okay, so let's take a look at how I implement. So the constructor is pretty simple. Okay, constructor basically you don't have to do anything. You just basically connect to the base class constructor RO server. That's all you need to do. But I want to show you what you do with. Let's try to look at the dump to JSON. That's probably easier one. So let's take a look at this remote procedure call. I have a 3-argument action, class name, and object ID. Okay. And this part you can neglect it. I just print out the timestamp because I want to keep a record about when this call was received. So don't worry about that part. But the interesting part starting this line, the if then else statement. So basically, I'm kind of hardwired saying that I'm expecting the object ID to be 1001. Okay, and the class name has to be labeled GPS. And I already have an object pointer called obj1001. Let me show you what obj001 was defined. obj001 was defined earlier over here. You see that what I did? I include label GPS and I declare object 1001 as a pointer to the label GPS, and I set the value to be null. Okay, I set the value to be null for this object. So what I'm doing here with a dump to JSON is that if, okay, no, this is not, this part is easier. So what I did here is I check if the pointer is a null or not. If it's null, don't touch it, okay? It hasn't been initialized. And whether the class name is equal to this or the object ID is equal to this, if any of this is true, I would say object or class not found, okay? Just give an error message. But if none of this is true, then I basically just call object ID is because it's a pointer, object ID to the dump to JSON and give it to the result. And then the status to be successful and return the result. I'm done, okay? And how do I deal with the object 1001? I basically create here. You can see that the first line of my main program, I basically create the object 1001, which is a pointer to the object. Now, the first time you see me creating an object using the new command to you called new. New is just like a malloc. Essentially, the syntax is I say new of the class of the object I want to create, and then provide whatever the bracket initialization, just like a constructor. So everything here is the same as how we create object before, except I'm using new. And this new is going to return a pointer to the object instead of the object itself. And so I assign that pointer to object 1001. By the way, to do this kind of server, it's really a good advantage using pointer. So I don't have to worry about one piece of code. I have to use the object here, but instead, when I do new, this object is actually somewhere else, okay? So take a look at CPP08. It will show you how you can use RPC to interact with an object that's actually not even running on the same machine. You can do that, okay? Okay, I have 4 minutes. I want to quickly go over 009. Okay, by the way, under CPP09, the program called ecs36b PO stands for proxy object. This file is identical to the file I created for CPP08. So let me just take a look at this. If you take a look at this, this is still this two function, set GPS label and dump to JSON. Okay, this is just two function. But the trick or the difference is that now I create another class called shadow GPS. So I want to tell you what that class looks like. Let me get rid of this, get rid of this, get rid of this. Okay, here. Okay, so I should probably remove this one. You don't need to worry about this one. Okay, so essentially I create another inheritance class, which is you're already familiar with GPS DD and label GPS. I create another class called shadow GPS, is inheriting from label GPS. Okay, I create another one. Okay, so what this is doing, I mean, first I'm going to run the program. It looks exactly the same as CPP08. So I'm just going to make and PO server. Okay, I create a service and then I'm running. I have to go CPP09 PO client. Okay, you see that I'm actually getting the same thing. The set is result, and then I got the label, whatever is the same. Essentially, by the way, this is the dump to JSON, but the dump to JSON is a dump at the remote. Okay, just like what we did before. But the thing is that you notice this is the client side. The client side, it says a GPS object called shadow GPS object was created. Okay, so let me give you, I have 1 minute, so I want to do this. So let's first take a look at the server side. By the way, the server side should be almost identical to CPP0A. So the only difference is what we handle the client side. Let me show you the client side first. Okay, let's take a look at the client side. The only difference I have is number one, I include shadow GPS.h. Okay, I create that. And then I create, take a look at the 3 line. This is interesting. I first create a shadow GPS object and provide the 3 arguments. What is the 3 argument? The first argument is a URL. The second argument is a class ID. And the third argument is object ID. So essentially, a proxy, I have 3 pieces of information to use as a proxy. By the way, what is a proxy? A proxy is not a real object. It's not a real object to represent that label GPS or whatever thing or whatever things you want or person, but instead it only provides what we call a routing information for you to reach the real object. Okay, so essentially it only needs the 3 information. I need a URL, I need a class ID, I need the object ID. Those 3 pieces of information is enable me to find the real object that's actually on the network. Okay. Okay, so after I done this, you can see that I do a shadow GPS, then I do our favorite subject casting. I basically cast the shadow object 1001 to GPS. So I converted from the bottom of the inheritance hierarchy to the top of the inheritance hierarchy. And I also create another pointer, which is I cast to label GPS. So essentially what I did here, I just want to show you that how you can play with the casting against such kind of setting. So essentially I have a 1 pointer casting all the way to GPS DD. And I casting all the way to label GPS. Okay, so now let's take a look at the code. How do I call it? When I call, let's first call dump to JSON. When I call dump to JSON, you see that, how did I call? I call GPS PTR, which is what? GPS PTR is a GPS DD pointer. So when the compiler take a look at this line, he said, oh, you want to do a dump to JSON. And you want to, and what object pointer we're dealing with? That's the GPS DD object, right? Because it's what is in the parent type, sorry, the ancestor type. And so you just basically run this program like this. And what the virtual function mechanism will look for the V table of the GPS pointer and realize it is a shadow because it was casting from the shadow. So from the shadow, it will call the remote procedure call to go to the remote and then call the real function. And this is very important because why is this important? This means that you don't really need to worry about where the object really is. As long as you provide, somebody provide the 3 pieces of information, all you need to do is I deal with something which is just looks like is a GPS object. By the way, programmer at this stage, whoever write this line, he has no concern about whether this GPS pointer is a GPS DD, it's a label GPS, or it's a shadow GPS. It doesn't need to worry about where the object is. It just care about, okay, I have an object here. As long as I can call this function, you have this interface defined as a virtual function, I will be able to pull out the information. Okay, so this has a huge impact when you do programming in a distributed sense because it's a transparency issue. You don't need to worry about that. Okay, we'll continue this subject. I will go a little bit more into 09 on Monday. Okay.